Let's explore SQL Triggers. This is an introduction to automating actions with database triggers. You'll learn how to use triggers to respond to events in your database. SQL triggers are database objects that automatically execute when a specific event occurs. They primarily respond to data modifications like insert, update, and delete operations. Triggers can be set to execute either before or after the action that triggers them. They are used to enforce business rules and maintain the integrity of the data in your database. There are primarily two types of SQL triggers: row-level triggers and statement-level triggers. Row-level triggers execute once for each row that is affected by the triggering event. They have access to both the old and new values of the individual rows. They are suitable for per-row validation and logging, but they can have a higher overhead with large datasets. Statement-level triggers, on the other hand, execute only once per triggering statement regardless of how many rows are affected. They do not have direct access to individual row values. They are more efficient for operations that affect many rows and are often used for aggregated actions and auditing. The basic syntax for creating an SQL trigger is as follows. First, use the create trigger statement followed by the trigger name. Then, specify the table that the trigger is associated with using the onTable_name clause. Next, determine the timing of the trigger using before, after, or instead of, and specify the event that will activate the trigger, such as insert, update, or delete. Optionally, you can include trigger attributes using the with_trigger_attributes clause. Finally, define the actions that the trigger will perform within a begin end block. Inside this block, you can include SQL statements and conditional logic using if statements. Let's consider an example of an after insert trigger, specifically for audit logging. This trigger automatically logs all new orders to an audit table whenever a record is inserted into the orders table. The benefits of this approach include a complete audit trail of all transactions, the removal of the need to modify application code, and consistent logging regardless of the entry point. The code begins with create trigger tar_orders after insert on orders after insert. Then, inside the begin block, an insert into order audit statement adds a new record with the order ID, the action which is insert, and the action date. The data is selected from the inserted table, which is a special table that contains the newly inserted rows. Now let's look at a before update trigger, used here for data validation. This trigger validates discount values before allowing an update to the products table. This enforces business rules at the database level, prevents invalid data from being stored, and ensures consistency across all applications. The code starts with create trigger tar_products_before update on products before update. Then within the begin block, an if exists statement checks whether the discount value in the inserted table is greater than 0.50, that is, 50%. If it is, then raiser is called to raise an error message and the transaction is rolled back, preventing the update. Let's explore an example of an instead of delete trigger, focusing on implementing a soft delete. This trigger implements a soft delete pattern by marking records as inactive instead of actually removing them from the database. The advantages of this approach include preserving historical data for reporting purposes, allowing for data recovery if needed, and maintaining referential integrity. The code begins with create trigger tar_employees_ instead of delete on employees instead of delete. Inside the begin block, an update statement is used to set the isActive flag to 0 and record the deactivated date for the affected employees. This is done by joining the employees table with the deleted table, which contains the rows that were targeted for deletion. In SQL triggers, two special tables are commonly used: the inserted table and the deleted table. The inserted table contains the new data for insert and update operations and is available in after and instead of triggers. Its structure matches the table being modified, and it contains all the affected rows. The deleted table, contains the old data for delete and update operations. It is also available in after and instead of triggers. It has the same structure as the modified table and contains all affected rows. Here's an example comparing old and new values in an update trigger. Create trigger tr_price change _audit on products after update. Inside the begin block, an if update price statement checks if the price column has been updated. If it has, an insert into price audit statement adds a new record with the product ID, old price, new price, and change date. The old price is obtained from the deleted table and the new price from the inserted table. Some of the best practices for working with triggers include keeping triggers simple and focused on a single task, adding meaningful comments explaining the trigger's purpose, using appropriate error handling, considering the performance impact on high-volume tables, and documenting all triggers in your database schema. On the other hand, common pitfalls to avoid include creating complex logic that's hard to debug, causing infinite trigger cascades, ignoring error handling and transaction management, creating triggers that negatively impact performance, and failing to document trigger dependencies. Let's summarize the key takeaways regarding SQL triggers. Triggers automate database actions in response to events. They can execute before, after, or instead of operations for insert, update, and delete events. The inserted and deleted tables provide access to the data being affected. Remember to keep your triggers simple, well-documented, and performance optimized. Common use cases for triggers include audit logging and change tracking, data validation and business rule enforcement, maintaining derived or calculated data, implementing soft deletes for data retention, and event notifications and alerting. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.